Okay, let's talk about the energy degeneracy in a 3D harmonic oscillator. We have a question here. The energy of a three-dimensional harmonic oscillator state is given as 9 h bar omega over 2. The question is, what is its degeneracy? Is it A, 6-fold degenerate, B, 15-fold degenerate, C, 10-fold degenerate, or D, 21-fold degenerate? To figure this out, we need the energy formula. The energy of a three-dimensional isotropic harmonic oscillator, that's one where the spin constant is the same in all directions, is given by energy is equal to, in parentheses, nx plus ny plus nz plus 3 over 2, all times h bar omega. Here, nx, ny and nz are non-negative integers, meaning they can be 0, 1, 2 and so on. Now the problem gives us the energy of a specific state, 9h bar omega over 2. So the first step is to equate this given energy to our general formula. We set in parentheses nx plus ny plus nz plus 3 over 2 times h bar omega equal to 9 over 2 times h bar omega. Let's simplify this. We can see that both sides have h bar omega, so we can effectively cancel that out. Let's also define n as the sum of the quantum numbers. N equals nx plus ny plus nz. This simplifies our equation to n plus 3 over 2 equals 9 over 2. To solve for n, we just need to subtract 3 over 2 from both sides. So n equals 9 over 2 minus 3 over 2. This gives us n equals 6 over 2, which simplifies nicely over 2, which simplifies nicely over 2, which simplifies nicely to n equals 3. So the sum of the quantum numbers for this energy state is 3. Next, we need to figure out the degeneracy for this n value. The degeneracy, often denoted as G sub n, for a given sum of quantum numbers, n in a three-dimensional isotropic harmonic oscillator, is the number of different sets of non-negative integers nx, ny and nz that add up to n. There's a handy formula for this. G sub n is equal to, in parentheses, n plus 1 times, in parentheses, n plus 1 times, in parentheses. Now we can calculate the degeneracy. We found that n is equal to 3. Let's plug that into our degeneracy formula. G sub 3 equals, in parentheses, 3 plus 1 times, in parentheses, 3 plus 2, all divided by 2. This simplifies to G sub 3 equals, in parentheses, 4 times, in parentheses, 5, all divided by 2. 4 times 5 is 20. So we have 20 divided by 2. This gives us G sub 3 equals 10. So, in conclusion, the energy state with E equal to 9h bar omega over 2 corresponds to a sum of quantum numbers, n equal to 3, and we calculated that the degeneracy for n equals 3 is 10. The state is therefore 10-fold degenerate. The final answer is 10-fold degenerate.